So here are the notes for solving systems of equations by graphing, and also introducing what systems of equations are. I'm going to skip the word problem here, although I'm excited to do that with you in class, or show you how a system of equation works in person. So what is a system of equations, though? It's two or more equations in the same variables, and it's also called a linear system. And a solution to a system of linear equations is an ordered pair in x or y that satisfies each equation in the system, or both equations in the system. So let's try to identify if this point is a solution to the ordered pair to the systems of equations. So it needs to be a solution to this equation and to this equation. So let's see if it's a solution to the first equation. So we'll plug -1 in for x and 6 in for y and see if that equals 8. And when you simplify the left side, you get 8. So that is a solution to this equation. That's good. But it also needs to be a solution to this second equation. So let's plug in -1 for x here and 6 for y and see if that equals 11. And yeah, when you simplify this, you get 11, and that equals 11. So that is a solution. So -1, 6, that coordinate pair is a solution to this system, because that system contained two linear equations, and it's a solution to both of them. Example number 2 is -1, 2, a solution to the system of equations below. Here's one equation, here's the other equation that belong to that system. So let's see if that coordinate pair, -1, 2, is a solution to the first equation. So we'll substitute in -1 for x and 2 for y. And when we simplify the left side, we get 1. Hey, so it's a solution to that first equation. That's great. Let's substitute this in for the second equation. So it's going to be 2 equals 3 times -1 minus 4. Unfortunately, the right side simplifies to -7. So this is not a solution for this equation. So then -1, 2 is not a solution for the system. It's got to be a solution for both equations. So that's identifying if a point is a solution or not. They gave us the point, but how do we actually figure out what a solution is? How do we create a solution? One method is by graphing. To graph it, we're going to graph both lines, and we're going to look for the intersection, because a solution is a solution to a system of equations must lie on the graph of both equations. So where they intersect is the solution to each of those equations. So we're going to graph them, figure out the location. I can tell you that on today's practice and on these notes, each solution, each intersection will be an exact integer coordinate pair, so you can identify the exact location. As long as you're doing a good job drawing fairly straight lines, or using the slope to put as many accurate dots on the graph as possible, you'll find that the intersections are integers. In the future, we might not have that, and that's where there's some other ways that we can find solutions besides graphing. So let's get to it. I'm going to graph this system of equations. I'm going to put this first line in blue. So the y-intercept is 4, and the slope is -2, which means I'm going to go down 2, right 1 from the y-intercept. Down 2, right 1, down 2, right 1. And because I want this line to be really accurate, I'm going to put as many points on this graph as I can, and then try to connect them a straight line. However, I know here I missed, but I know that this is actually where I want to be going through. So then the second line, our y-intercept is -2, and our slope is 4. So I'm going up 4, right 1 from the y-intercept. Up 4, right 1. Hey, there's my intersection. I'm going to keep on drawing the line, but the solution to this system of equations is where the intersection is. So it's at the point 1, 2. 1, 2. And like we did, if this is a test or there's $50 on the line here, we just want to make sure that it's right. If we plug in 1 for x and 2 for y, we should find that it is a solution to this equation and a solution to this equation. And that's cool. That's our solution to the system of equations. And as I calculate that quickly in my head, it works for each. That's awesome. The intersection is a solution. Those last two lines were in slope-intercept form, whereas these are in standard form. In standard form, you can get the x-intercept by plugging in 0 for y. In other words, hey, what does x equal when y is 0? So on this first equation, I will plug in 0 for y. And the cool thing about that is, like, -2 times 0 is 0. So really, I get x equals 8. When y is 0, x is 8, and I can plot that. And to get the y-intercept, I'm going to plug 0 in for x. When x is 0, what is y? Let's find out. So 0 minus 2y equals -8. Well, I don't really need to undo that 0. It's nothing. I just need to divide by -2. So I get y equals 4. When x is 0, y is 4. For the other line, for the x-intercept, I plug 0 in for y. Oops. So what is x when y is 0? Well, this one's kind of a easy equation. I plug 0 in for y to this. X is going to equal 1. So that's my x-intercept. I'm going to keep on going for a second here. I just caught a little mistake that I made. Here, my y-intercept, I'm going to plug in 0 for x and figure out what y equals. Well, y is going to equal 1. So I notice I just made a mistake in this first equation that I did in green. When I wrote this equation down and got the x-intercept, I didn't copy it correctly. This is a -8, and for some reason I wrote a +8. The x-intercept here is actually going to be -8. Oops. So that should be right there. So here is, I'm going up 4 and right 8, or up 2 and right 4. So here is that first line. And my second line as I continue those dots from these first two, I realize that the slope is -1. So I can buzz a line. Ooh, I can buzz a line. The intersection's right here at -2, 3. Now maybe I calculated something wrong. Maybe that looks like a good answer, but it's not right. As I plug those values into each equation, it is correct. -2, 3 definitely is the one point, the exact point or location of solutions. So on your practice here, you'll be graphing these lines and finding the intersections, and that is your solution to the equation, or to the system of equations.